So let's go ahead and continue on with the next subject. So the question becomes, well, if I have more than one mutation rule, what order are they evaluated in? And realistically, the answer is just some arbitrary non-deterministic order, right? The idea is to try and separate the concerns of your plugin so that one's not overriding elements of another, but there are realistic use cases to do that, right? So basically, the order of evaluation of rules for a particular subject are in this order, right? So I can define a default rule, which will apply defaults to a particular subject before any of the other rules, mutation rules on that subject are applied. And obviously, mutate is the default sort of ordering. Finalize comes after all the mutation rules. And then there's a final one called validate. And really the intention of validate is that all the rules that could possibly touch something, including finalize rules, have been evaluated. So basically I can do validation saying, oh, hey, this isn't a valid input or something like that. So basically the validate rules are called just before a model element is going to be used as an input to something else. And basically, in this case, the subject is not mutable, right? So I shouldn't be changing the subject in a validation rule.
Can there be more than one default or finalize?
Yep. Yeah, so the question is, can I have more than one of each of these? Yes. You have any number of them.
So are these applied on a per rules basis, or are they applied categorically, like everybody's defaults are done?
No, so the question is, do I do all the default rules, then all the mutate rules, then all the finalize rules? And the question is, no, really, that's not the order in which we evaluate things. We do the defaults rules, then the mutates rules, then the finalize rules, and the validates rules for whatever particular input is going to be the input for this rule that we are then evaluating. So again, this is all a graph, and we're just going to calculate the graph and whatever we decide is the most efficient way to do it in order to define the model for whatever you're trying to do. But yeah, so that basically that's arbitrary and an implementation detail that has no effect, right? Whether I do the default then whatever for this subject, then this subject, then this subject, or all the defaults and all the other ones, the end result is the same. And the result being that all the mutate rules for any given model element will be executed by the time that model element is an input to my rule. And that's all I care about, is this thing is done by the time it gets handed to me.
Then why have the mutates and the defaults if it's all going to be just applied in order of the same object?
Because if I have two mutate rules, but I want to define their order, I have two things that mutate my person, but I want one to come before the other. I can say one is a default rule, or one is a finalized rule, which should come. So this is basically, I mean, the names kind of imply what their use case is supposed to support, in the sense that the default rule populates defaults. Like maybe I use it to set conventions, and then the mutate rules are what the user is going to change. And then maybe as a finalized rule, I say, hey, if the user did this, like a finalized rule might be, this is a plugin that I write as part of my organization to enforce some kind of governance, and I want it to run after anything that's in my in my user's build scripts, right? So it's just an enforcement type of thing.
So would that mean I'd have multiple mutates? I would only have one default and one finalized? Or?
You could have multiple of any of these rules.
And then what's the order within defaults?
It's not no particular order. Yeah. Okay. So like I said, all rules are evaluated before a model element is used as an input, right? And that's the whole point. Is before, when I ask for something, it has been completely configured before it gets used as an input to another rule, right? Right. Other rules, otherwise they behave identically to other ordering rules. Otherwise, to behave identically to mutate, right? Only a single annotation should be used, right? So you don't do defaults then mutate. Defaults is effectively a mutation rule that just happens at a certain time. And all rules created via the model DSL are effectively treated as mutation rules, right? And we'll talk about the model DSL a little bit later.
Are there guarantees that only one thread will be acting, performing one of these mutations? If you have 5 mutates, is there a guarantee that only one of those mutates will be used?
So conceivably, right now we're not doing configuration in parallel, but conceivably we could. But effectively, there's no contract. So the question was, could I do multiple mutate rules in parallel? And basically, once we start to parallelize configuration, yeah, we'll make sure that we can enforce thread safety in the sense that I'm not touching this thing at the same time another thread's touching it. But that does also mean that I could have a thread doing configuration, another thread doing configuration. And again, this mutate rule and this mutate rule, the order in which they get evaluated, right? We're not making any promises there. There's no, right, there's no contract there. But we do guarantee that all the default rules will get run before all the mutate rules, right? And this is kind of the question was, well, what if I have a bunch of mutate rules and they're all modifying the same subject? Really, the answer to that question is that if I have a model rule in some plugin over here and a model rule in some plugin over here, and they're both setting the same property of the same thing, it kind of implies that maybe we're not separating concerns properly, right? It maybe implies that we're not modeling our domain properly, right? Because there really should be there should be one source of truth for whatever your decision you're trying to make. And ideally, the plugin wouldn't make any decisions, and then the build author, right? You would use defaults to set conventions, and then you're assuming that in the DSL, the build author is going to set what their version wants to be, right? So it just kind of depends, right? Same thing. I mean, I could overwrite the same value, but it kind of indicates a different problem, right? Which is really just a complex way of saying maybe you're doing it wrong. If that's the politically trained way to do it. That's a different problem, right? Okay, so there's actually another lab on this. This one's pretty quick and easy. So for all these exercises, for the most part, we give you everything you need just to do what you need to do. So effectively, this lab already has a plugin, a rule source plugin that creates that task or whatever, right, and creates a greeting model element. All you're doing in this case is you're defining new mutation rules using the different annotations. We're just going to basically show that they come in the order that you expect, right? So we'll just take a couple of minutes to have everybody kind of play around with this, and then I'm going to walk through this exercise too. It's going to kind of show you exactly what it does. But I want to make sure that we get through everything. All right, I'm just going to go ahead and walk through this lab real quick. And if you didn't get a chance to finish it, that's all right. But I just want to make sure we get through all the material. We got about an hour left, so. All right. So here we have my rule source plugin, right? It's the same thing that was in that example, right? In this case, you'll see here I'm creating my defaults rule, right? So the model creation rule up at the top just creates a new empty greeting object, right? And then in my defaults rule, I'm going to say, hey, I'm going to set the salutation to some string and the subject to some string. So when I run my task, I get what was set by the correct rule here. Is this just cut off? Oh yeah, it's just cut off. That's awesome. Yeah. So cut off a little bit, but you get the idea, right? So now you'll see here, if I uncomment my mutate rule, right? This one sets the salutation to good day. And if I run the task again, right? Now I say good day. That one runs after the default rule. And same on down the line. If I run the finalize rule, it runs after all the mutation rules. So I should say good day world, which is what I expect, right? And then finally, after everything, we'll say I'm going to run my validate rule, right? And this one's saying if the salutation is greater than 10, they'll throw an exception, but in this case, that's fine. Good day is not more than 10 characters. But if I type some stuff in here, right, then we go, okay, the length of salutation cannot be more than 10 characters, right? I'm actually going to validate the model, which this avoids the, task graph, when ready, if has task, if this thing is not right, throw exception nonsense, right? Question?
Yeah, so in my validate rule, I went ahead and said reading.salutation equals foo.
Yes.
It did not error out. Did you say that that's not implemented?
Yeah,
Isn't implemented?
that's not, yeah.
Okay.
Eventually, that will be the case. We'll actually enforce immutability there. I mean, really, the case is, that's actually not exactly true. With unmanaged elements, and by unmanaged I mean where you create the new object, we can't enforce immutability, right? We don't own the implementation for that greeting object, so there's nothing we can do about that. But for managed model elements, which we're going to talk about next, in that case, we do enforce immutability, and we will.
Except not yet.
Yes, we have in every case except for the validated case. And there's actually, right? So if I was to have it like in, we'll talk about it in a second, but in this case, if this was a managed model element, and in this mutation rule I tried to modify this input, I would get an error. Right? Yeah. Yeah. But validate should be doing it. It just doesn't happen to be doing it in the particular build of Gradle that we're using. But that's a trivial change, and we'll fix that.
Oh, you're saying because it's an input, yeah.
Yeah. Yeah. We do for inputs, and we should for that one, but we don't.
Okay.
Right. So. All right, managed types. So that's what I was talking about. In these previous examples, these are unmanaged objects. These are just regular POJOs, instances of objects you create. All right? So when we talk about managed types, what we mean by that is we mean some object for which Gradle has provided the implementation. Right? And what this allows is for a lot more control and safety, right? So we can say, right now the rules, we execute them in the same order, but really if an unmanaged type is an input to a rule, right now technically that rule can modify that input, but it shouldn't, and that would break that contract, right? So the idea behind managed types is we actually enforce that immutability, right? So if a managed object is an input to a rule and you try to mutate it, we actually throw an error, right? You can't modify this object because we promised this other guy that no one's going to touch it anymore, right? And it's like, you can't make me break my promise to this other person, right? It also improved performance. Adam talked about this a little bit. The normal sort of Gradle objects, or they're these groovy objects, and we decorate them with all this stuff, with extension containers and all this stuff. And they're very heavyweight, right? They have a lot of dynamic runtime stuff associated with them, so they're just naturally kind of non-performant. But the managed types, because we build the implementation for them, they're very performant, right? It's Java. There's none of that dynamic groovy stuff going on. So we can guarantee that the implementation of those types is very, 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 very fast. Right? And mainly the difference is that managed types are defined, and you just define the type using the managed annotation. Right? So there's some rules with that. All right, a managed type must be an interface or an abstract class. Right? It's kind of the whole point. Right? We control the implementation for this type, so it can't be a concrete type. It can't be something you can instantiate. Right? It may implement the named interface, which really is just a simple interface that defines a getter and setter for a property called name. And what that means is if you take that object and you put it in a model map, we'll use the name property as the name of the model in the element. Right? It may inherit from other managed types. So managed types may have a class hierarchy. That's perfectly fine. And it can provide implementations for read-only derived properties. And really we mean this by like computed properties. So if I had a person type and it had a first name and a last name, I could have like a get full name property that returned the value of first name and last name. I can't have a setter. It's just a getter. And you can either make it an abstract class and define it as a concrete method, Or if you're using Java 8, you can define it as a default method on the interface, right? You provide an implementation for that method. And really, you just define the type by just defining it as you would any normal Java bean, using Java bean conventions, right? Getters and setters. So there's some restrictions on what the allowed property types are on a managed type. But we support all these types: string, boolean, carrier, integer, long, file. We're going to talk about model set and model map later. So these are the collection types. Or another, it could have a type which is of another managed type. Also enum types, it supports that, but I forgot to list it on this slide. And also you can create model maps of managed types. And ideally, that's the way you would create your DSL, is this way. All right. So instances of managed types are created using model rules, just like we saw before, right? So I define a creation rule, but instead it's creating, instead of some instance of some class that I defined, it's creating an instance of a managed type that I defined with the managed annotation. Right? And so because of that, the method signatures for there are a little bit different. So instead of returning the object, these rules return void, and they get passed the instance of the managed type as their argument. And just like other rules, they can have any number of inputs. So so this makes a little bit more sense. This is kind of what a managed type creation rule would look like. So at the top, I'm defining a new managed type. In this case, I'm defining it as an interface, but I could just as well define it as an abstract class with abstract methods. So I'm basically saying it's just going to be something called person, and it's going to have a property called name, right? Get and set name. But I don't provide, it's an interface, I don't provide implementations for these methods, right? And now I'm going to create a creation rule, and it's going to create an instance of that managed type. So instead of it returning of type person, and I return new person here, instead Gradle creates an instance of this type, right? Because we control the implementation, and then we just pass the instance of the managed type that we created into the rule. Right? So question?
Inferring the properties based on those types, is that what you're saying? Based on the getters and things like that?
Yeah, so the question is, are we inferring the properties based on those getters and setters? Yes. So we're inferring that this should have these properties based on the naming conventions. They're just regular Java Bean naming conventions. Right?
That's a model rule, not a mutate rule?
Yes. So the question was, this is a model rule, not a mutation rule? And yes, because this is defining a new model element.
So the managed block doesn't create a new instance? Or doesn't create a new
No, so this isn't creating anything. We're just defining a type.
We're just saying this exists. Okay.
This is a type of thing. Yep.
So it's not returning person
No.
in the second block.
Yes. So this doesn't. Yeah. This doesn't have a return type. This is a return type void. So remember that if you guys were in Luke's talk and he talked about like some of these, the conventions for defining some of the rules are maybe not super pretty and not super intuitive, and that eventually what we want to come up with is some syntactic sugar, some easier way to define these rules. So yeah.
The exact details still incubating.
Correct. So yeah, still incubating. This stuff might change in the sense that there will probably be easier ways to define this stuff, so you don't have to go, oh crap, I said it was of type person instead of type void. Oops. So yes.
Do you have to provide public there, or is that gonna break?
Oh, so the question is, do you have to provide public here? Yeah, you normally would. Basically this example I wrote in a Groovy script, so I omitted it. So it's a little confusing, right? And I'm assuming this is in a build.gradle, so it's Groovy, so the default access modifier is public, right?
So not to go on the syntax anymore, but actually, if all you wanted was the person, you wouldn't have, and you didn't want to set the name, you would just have an empty method.
Yeah, so the question was, if I just wanted to create a new model element of type person, but I didn't want to mutate in any way, yes, you basically, this rule would have an empty implementation, right? So I just wouldn't have this line. I could just as well implement this basically the same behavior by defining this without this line, and then I have a mutate rule that uses the person as the subject and then do it in there, same thing. This is just sort of you think of it just like you create tasks and stuff in build scripts. I'm going to create something, and then I'm going to configure it. right? This is the same thing. I'm creating something. I'm asking Gradle to give me a new instance of something, and I'm going to configure it just kind of in one step. Go ahead.
Is there a reason why you would use why you would set your defaults in a model or use the add defaults mutator to set your defaults?
So the question is, would you set your defaults in the model or in at defaults? The answer is, and actually this is the question that Stepan asked earlier, is actually in the case of managed model elements, the defaults rule actually runs before this one, which is not super intuitive, but something to take into consideration. So if I define a default rule for a model element that is a managed type, actually that rule comes before this one. And effectively, this is treated as a mutate level. I sort of scented like a tone in that question. The yes, with the intention that unmanaged stuff goes away, if that makes sense.
So if you want to have a mutate method, you would still be required to have a model method, even if it's empty.
That's correct. So I could, yeah. If the question is, if I had a mutate method, I'd still need the model method. Yes, because the model rule, this is a creation rule. This is what's creating that model element. So I can't, if I had just a mutate rule and had a managed type as a subject, basically you get an error saying I was unable to bind that subject because I didn't find anything in the model for it. So yeah.
So if defaults rule runs before this, will that create the object? If you don't have the model.
So the question was, if the defaults rule runs before this one, will that create the object? No. So the defaults rule doesn't, if I just have a defaults rule, that's a mutation rule, won't actually create a model element. But it's really, so it's somewhat non-intuitive because you're saying that these elements of code are executing different times. So what's creating the model element? Gradle is creating it based on the existence of a rule, right? We know that there's a rule, right? I know that you want to make a model element. I don't have to execute the code that's in here to make that thing, right? You're describing to me that one of those things should exist by pure virtue of defining this rule.
You said something there real quick, it kind of blew my mind. The whole business regarding the question with the defaults and all that, you said in the hopes that unmanaged would go away in favor of managed, but unmanaged gives you the opportunity to put in additional logic. Maybe I have to go out to a file system or read something or do something. Where would I put that? In an abstract managed?
Yeah. So the question is, I said before that the goal is eventually that unmanaged objects go away, right? And then the question is, okay, then where would I implement my custom configuration? You would put it in a rule. You would put it in rules, right? So instead of having a property on a managed object that did some work, really I would define a rule that defined as an input or a subject that model, and that rule did that work. Correct.
So if the default is then applied to every single instance of that managed object, or is it again a PI instance?
So the question is, does the defaults rule apply to every instance of the model? The default rule applies to whatever you're binding to. So if I'm saying I'm binding to person, and there exists exactly one person in the root of my model, that's what I'm going to apply to. If I say defaults person and there's two, I'll get an ambiguity error. I have to tell you which one. So defaults isn't by type, it's by actual instance of a model element I'm binding to. Correct.
When do you use the model binding? What's the advantage of default then? I assume default is then for all the same, but what's the advantage of having default in addition to model?
Because I could define a defaults rule in a different plugin than the rule that's defining that model element, conceivably. Right. That's the benefit.
And just to follow up on the follow-up, so given all what you said, we should then prefer creating managed objects
Yeah.
as opposed to unmanaged when
Yeah, so the question is, should we prefer managed types over unmanaged types? Yes. Yes, 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 yes. So you should implement your plugins using managed types if at all possible. If for some reason your particular use case cannot be implemented via managed types, basically that indicates that our managed type implementation isn't there yet, right? So if you have a use case that can't be implemented with managed types, that's a use case we want to know about and we want to be able to support. Okay? Yes.
So where does the custom DSL? So I see how
Yeah. So the DSL stuff the DSL we're gonna talk about in a second.
pass it John or Bill. Or
Yeah, we're gonna talk about DSL in a second. Right after we talk about the managed, we're gonna talk about DSL like at the end. Right now we're just kind of talking about how do you do stuff with rules. So the question is, well, how ideally I'd set this value from a build script via the DSL somehow, and yeah, we're gonna talk about that syntax and how that works. All right. Another option is if I absolutely do need to put a property of an unmanaged type on a managed object, we do support annotating it such as unmanaged, but we don't get the immutability checks and stuff like that if you do that. All right. So the third lab is on the managed type stuff. And basically we're just going to re-implement the same thing we did, but instead our greeting thing is going to be a managed type. So we're just asking you, instead of creating a model of an unmanaged object, we're going to redefine this greeting class down here, change this guy to be a managed type. Right? Yeah, you got a question?
Yeah, you mentioned it, I just wanted some clarification on the defaults run before model you use an interface.
Yes. Yeah. Not.
What's the use case there? Like,
The idea
you
be.
can create the model without doing a set, whatever, right? And then the default value will be there. Is that the idea? Is that the architecture?
Yeah, it's in that case, it's more likely the case is that some base plugin. Basically, I would have a base plugin that created the model elements and wired them up to do some work. Kind of like we have the Java base plugin that creates the notion of source sets, and when you create a source set, it creates a compile task, but it doesn't create any source sets for you, right? So then the idea is that I would have a Java base plugin that would create my managed type, but it wouldn't add anything to it, and then I would have another plugin on top of that that created conventions in the form of defaults. Does that make sense? So the reason is that I want to create something and I want to set a default value to it, right? But that's going to conceivably be in a totally different plugin, right?
But the default would be overwritten by the managed,
By mutate, which is what I.
by the model.
No. Oh yes, in that case they would, and because the models effectively, really in that plugin, my base plugin, I would create an empty model because I'm assuming someone else is going to override its defaults. But I want maybe a plugin to say, oh, here my default says I have a main source set and it lives here, but then in my build script, I want to say no, my source lives here. So I want them to run in the order in the sense that my base plugin creates this thing, but it's empty. My convention plugin adds some conventions, and then my build script overrides maybe some of the conventions, right, to sort of facilitate that use case. Right. It's the same thing we do with the Java plugin. We have a base, Java base, and Java base creates the elements, the DSL declarative elements, and then the Java plugin assigns basically default convention values to them, right? And then I can override them additionally in my build script. Same idea. So basically what we're trying to do is, in this example, this is the unmanaged stuff, right? And what we're trying to demonstrate in this lab is, really two things. One, how you basically implement the same type of thing with managed models. And two, what is the benefit you get from using managed types? Like what are the additional stuff that Gradle can provide for you if you're basically manipulating instances of an object, and now we own the implementation too. Okay. So really, it doesn't look much different. The main difference is you got to make sure that the creation element returns void instead of the type, and you don't return anything, right? You just specify the type of the managed type as the subject of that rule, basically. And then instead of defining an actual class, you define an interface or an abstract class, either one. Annotate it with managed, and then just define basically the interface contract. Okay? So we get, really, we're not going to see any difference, right? We're going to get the same results I print out. Okay? So it behaves, this managed type behaves exactly the way that unmanaged one is. But we asked you in the last step is, okay, well then go ahead and try and mutate that greeting in this rule, right? So basically what we're saying is this greeting object is this fully realized part of our model that's an input to another rule. And now that rule is going to try and modify its input. And if I run the task again, and typically I have to save it. Oh, that can't possibly be right. Hopefully I am. I'm in 4. Woo! I was like, ooh, I'm gonna look silly. All right. And you get an error, right? And saying, this is the model rule I tried to execute. It's doing something nasty. It's trying to mutate something that's been closed, right? It's trying to mutate this greeting item. You can't do that. You can't modify something that we basically promised to have been done being configured to other things, right? Because there could be other mutate rules that also take this thing as an input. And if I'm modifying them as part of my mutation rule, I start screwing everything up, right? That's the whole configuration ordering mess nightmare that we're trying to solve. And we solve that problem using managed types by actually enforcing that in plugins and saying you can't even do, we're not even going to let you do that. Right? Yes?
If I pass into a mutator a dependency, will that cause the dependency then to get resolved?
Currently, that's not possible, right? Is- yes. So the idea that would be that the dependency resolution process would be mutation rules on the dependency, right? But currently not at the moment. Was there another question? Yeah.
Yeah, but this is actually, this was our interface, right? We declared the interface. It was not something that came from Gradle in a distribution.
Correct.
So interface, we can declare the interface, but it's managed by Gradle.
Correct. Yep.
Could be anything.
Could be anything. Yep. And it could have types that are other managed types and so on and so on and so forth, right? So the idea is that we model the declarative elements of whatever we're trying to describe in our new domain with managed types, right, instead. And then we get all that benefit. Okay. So let's keep going. All right. So model collections. So the configuration model defines 2 new primary collection types, right? Model set and model map, right? Naming makes some sense here. And effectively, they behave just like sets and maps, right? With maps, they have items that have unique keys or names. Sorry. Are we good now? Okay. So maps is a set of entries that have a name, right? And the name is effectively just the key of the entry in the map. And these collections are model aware, which is kind of like Luke was talking about in his set, where if I create a new item, if I tell the model map to create a new item and add it, and I provide some configuration, that configuration actually isn't evaluated until we need that particular element. right? So effectively, these collections are aware of the configuration model, and that configuration that we pass into the model is implemented really under the hood as just another mutate rule. Right? So really for the purposes, I mean, this is kind of an oversimplification, but for the purposes of going from legacy plugins to new rules plugins, a model map is what used to be a polymorphic domain object container, right? Is some named collection of things that all extend from some kind of base type, right? And then a model set is just a domain object collection, just some collection of types for the most part. Their interfaces are not exactly the same, but very similar. So you can create model elements of type model map or model set. But the collection type, basically, the generic type argument you pass, must be of a managed type. Right? So in this case, we've redefined our person type to be a managed type. And now instead of saying I'm going to add a new thing called person, more than likely, a more realistic use case would be I would add a root model element called persons, and it's going to be a collection of these things, right? And then my build script is going to configure one or more of these new types of things that are some new element as part of my new domain, right? So in this case, I'm defining, in this case, a model element, right? The model element is called persons, right? It's a map, model map of persons. And I'm also going to go ahead and create a new one, some person with the name John, right? So now I have a root model element called persons, and there's one person element in there, and the name of that person is John. So you can nest all this. So I can have managed types that have properties that are collections of managed types, and so on and so forth till, you're completely content. So in this case, another some sort of more realistic example would be I have a managed type that's organization, and an organization has a collection of members. And members are person objects, right? In this case, I just put the interface, it doesn't have any properties or whatever, but you get the idea. Right? So now one of the cool things is I can actually specify as an input to a rule a particular item of that collection. I can actually say, okay, I'm going to create a model map of organizations. I'm going to create an org called Gradle, right? In this case, I'm saying that the members property of the Gradle organization is my subject that I'm modifying, right? And you can do the exact same thing for inputs, right? So this is more likely the kind of thing you want to do. You want your rules to be sort of very discrete and very small, right? What do I really need as my input? I need this very specific thing, right? So I'm not gonna mutate this whole big giant collection. I'm gonna try and scope it down as much as possible so that my dependency graph is as small as possible, right? Got a question?
Here there's only one argument of create, but how are the arguments of the create method?
Yeah, so so basically, in this case, this is a map. So this is going to be basically the key of the item in the map. This is going to be the thing's name, right? Does that make sense? And then optionally, I could provide a closure that would configure and set additional properties on that thing. Yeah. If this was a model set, this wouldn't. I would basically just say create just a new thing without a name in the set, right?
So it's empty.
Huh?
So it's an empty.
Yeah. So this organization has no members.
How about when you create Alice and Bob? Does that translate into actual names of the persons?
Yeah. So we're going to assume that if an item implements the named interface, we sort of tie those two things together. But really, it's just saying, I'm creating an item, I'm putting it in a map, I'm creating a new person object in a map, and then the key that refers to that entry in the map is Alice. That's really all that means. So think of, this is just like the named domain object containers that you're used to already, right? I have a source set, and its name is main, right? It's a type source set object. The name is main, and source sets is a collection of things, but they all have unique names, right? So model map is the same thing. It's a collection of things. Those things are referred to by some kind of unique name. Tasks is kind of the same idea, right? A collection of tasks. A task has to have a unique name. Okay. So, are there any questions on what's going on? This API is kind of important, right? Does everyone kind of get this bit, right? This is the name of the thing I'm making. And then I could optionally provide a closure that would configure it. Right? Hmm? Assuming there was something in the model called foo. Yeah, so the question is where's this path coming from? So here I'm creating a model element called orgs. So this is at the root of the model, right? Then I'm adding something with the name Gradle to that model element, right? And actually organization, and this might make more sense, organization is a thing that has a property called members. So this is the members property of this element of this collection. Right? So I can scope things down very specifically. Yes, I'm creating a new organization, and I'm just giving it a name. Just like I would create a task and give it a name. Right? Okay. So, next exercise. Come on. So let's talk about this example here real quick. We're running short on time. So, all right, in this case, I have the same managed element. I still have the same greeting object, right? But now instead, what a more realistic use case would be I would configure some arbitrary number of these things, and then for each one that I create some task that goes along with it, right? So up at the top, I'm going to define my managed model element, but instead of it being a greeting, it's a model map of greetings, right? And Gradle knows how to take care of this. It knows how to create model maps of managed types, right? And then second, I'm going to go ahead and create a mutation rule that's going to mutate that collection and add a couple of items to it, right? And then finally, I'm going to create a mutation rule that for each of my greetings, and at this point, that collection is immutable. No more items can be added to it, and all the items that have been added to it haven't been messed with. I'm going to iterate over them and then create a new task that prints that out, right? So if I run Grail Tasks, you'll see I have my polite greeting and my rude greeting. If I run my polite greeting, it's very friendly. And if I run my rude greeting, I get, it tells me to screw off. Okay. Yes. Okay. Yes, question.
Is it possible, like he said there, is it possible just to say greeting stuff?
Eventually it will be. Boy, I wish I had a better answer. So this is one of those elements in which the API isn't quite as functional as we would like it to. But yeah, the intent would be that you would be able to iterate over that map just like you would a normal map. But currently, that's not the case. So again, this is all very highly active in development. Right? So there's still some bits that haven't been completely perfected, and that's one of them.
How did you get those tasks we just built in this?
Just Grail Tasks. Assuming you didn't give them a group of description, they should show at the end under other. But, yeah. All right. So the model DSL. So, yes.
The mutate operation for such a collection, is it only suitable for adding new elements, or can you also remove elements that have been created by another rule?
Should be able to, right? No?
There's no complicated removal right now. So short answer, no. As long as yes, you can say remove that guy, replace it with this guy in a mutate operation.
Okay, you can replace it.
Yes.
Plain removal would be quite non-transparent from an introspection view. At the end of the day, you only have the final operation. If you, for elements that are not there, you could not find out who removed them.
We can track that.
Okay.
All right. So we just got 15 minutes left. We might go a little late. So the last major bit as far as the configuration model stuff that I want to talk about is the model DSL. Right. And basically this answers the question of, okay, well, I don't want to have to do all this configuration in a rule source plugin. I want to be able to do this from a build script, right? How do I do that? How do I create model elements? How do I configure them, et cetera, from a build script? And basically, we can create rules and define them via DSL in our build script. And we just do that by putting those rules inside of a model block. So all that model stuff, there's a top-level model block in our build script, and it goes in there. Right. So model DSL, you can do both creation and mutation rules. So you can create new items, create new model elements, and mutate existing ones both via the DSL. And we have currently this sort of temporary jQuery-looking syntax to define the rule inputs, right? So I say this is input to my rule, and we pass the path to that thing. Right? And so this is more than likely going to change in the future to be a nicer way of doing the input stuff. Right? So we're going to assume you're going to use this as our example. We have a greeting, right? This is kind of the thing we've been doing before, creating a task called print greeting, creating a model, but we haven't actually configured, we haven't set anything on our greeting here, right? This is a rule source plugin that just defines a new type of thing and then creates a task that reads the input from that, but we haven't actually mutated it in any way, set any properties. Assuming we're going to do that from our build script, right? So I'm going to mutate that object in this way. So I'm saying that there's a model element named greeting, and that model element has a property named message, and I'm going to set the value to hello world. And the same thing, that creates a rule, a mutation rule, that is executed before the greeting is used as an input to this task. So that when the task executes and the task is created, it's configured properly to print out my value. So basically, we treat DSL rules the same way we treat method rules. So whether it's a mutation rule in the DSL or it's a mutate annotated rule on a method in a rule source, they're treated exactly the same way. And we do all the ordering to make sure all the configuration happens at the right time. Right. And so all mutation rules, to include those defined in the DSL, are to be evaluated before an element is used as a rule input. Okay? Which means no more after evaluate. Right? Right? We don't have to worry about that. So in my plugin, I define a rule that defines a new model element, and I define a rule that creates a task that reads from that model element. I don't have to worry about what might possibly poke that thing in between those two steps. That's irrelevant to me. That Gradle will figure that out.
But names specifies within the model block, but again, the root of the model block, so we have again from like conventions and logic. If I create a convention majority, which contains properties majority defined, and I share the old one of the square amount, get an error or something. Again, with rules, I add directly to the root of the model. So when two plugins add now a greeting object or a greet or whatever, then
Yeah, so
we get an issue, right?
yeah, so the question is, if I have two different rules and they both try to create a model element with the same name or with the same path, really, yeah, that's going to be a conflict, right? So
Why, I mean, with extensions, this problem is solved, right? Because with extensions, I get
Yeah, so the idea is we would create the same type of model with managed types. So I would create a model element that had some kind of unique namespace specific to whatever my domain was, and then it would just have a bunch of stuff under that, right? Would typically, so you would create a model element type that looked just like an extension, same type of deal. So we get the same concept. So if I'm creating a Jacoco plugin, I'm going to create a model element called Jacoco with a bunch of properties on it that set how to configure my thing. So hopefully there's no other plugin that also tries to create a model element called Jacoco, right? Yeah, we're gonna trademark that, right? So no one else uses it. Okay? So we can also create model elements the same way via DSL rules. So in this case, we're creating a model element of type greeting and then configuring it with a message. Right? Creating a new thing of, and then in the parentheses we pass the type. Right? And that type could be a managed type, right? It could be just an interface, which is a managed type, and Gradle knows how to create it. Right? We can also do this for collections. In this case, tasks is a model map, right? I'm creating a new item inside that model app called print greeting, and I'm saying it's just a task, right? Or it could be a copy task or whatever the specific type of task it is. In this case, it's just regular generic task. And then I'm configuring it with a task action, right, to print out the greeting. And in this case, I'm using the DSL input syntax. I'm defining the message of that model element is an input to this task, right? It's an input to this rule. Just a note, to use this syntax currently, you have to explicitly enable it on the command line right now. So what was it? Just to use the input, the $ such and such syntax. Yeah. So eventually that's going to be defaulted to be on. Right now it isn't. So just take that into consideration when you're doing the very last lab. So we'll give everybody a couple of minutes to kind of play around with it, but we got a few more slides to go through. Okay. We also call it the component model or new component model. And basically, this is an abstraction on top of the new rules-based configuration, right? And it's basically the idea that the new configuration model is domain agnostic, right? It's just to allow you to describe any kind of domain. So really what we need is a more specific way of describing how to build software, right? So the idea of a model of managed types that are somehow related is really generic, right? So more specific than that, we want to provide an API that allows folks to describe very specifically how do I build software and what are those bits and pieces and how do they relate, right? And very simply, software is generally comprised of components, and components can produce one or more binaries. And then in Gradle land, tasks are what finally pump out the binaries, right? There's going to be some task produced for creating a particular binary. So it kind of looks something like this, where I have a component. An input to that component is source, and it could be any number of sources. It could be C and C++ source, or Java and Groovy source in the case of JVM space, right? That component can create multiple binaries, right? I create an x86 binary and 64-bit binary, and even a jar. I can produce a jar for Java 1.6 or one for 1.7, et cetera. And then there might be several tasks that are responsible for generating that binary. So in the case of the native space, right, I have a task to compile my code, then a task to link it, into the object file, et cetera. And that finally pumps out a binary. So these are sort of the unique bits of what a build should be comprised of. Okay. So what we're trying to develop is some kind of API that's very generic and that folks can extend, so that you can use the software model to provide support for building whatever language you want. Okay. And so again, there's a few main types, and this is kind of like source code overload, but this is basically examples of what it would look like. In this case, I'm registering a new custom type of language, source set. And again, this is developed as a rule source, and we have this special language type rule annotation that's telling Gradle what this rule is doing is it's registering a new type of language. And we're just calling it custom. Right? Same type of thing goes for types of components. I define a new component type. I create a rule, extends component, annotate it with the component type annotation. So Gradle is now aware that I have a new type of thing I can build. Right? Right. Same thing for binaries. Right? So a component can conceivably create multiple different binaries. And then we define rules that do this mapping, right? So basically I have to say, for every given component, here are its binaries, right? Because any given component can create multiple binaries. So the component binaries annotation is basically, here's my binaries that I'm creating, and then I get as an input to this rule each of my components. So it's almost like a rule that we iterate on for each one of these that the user has defined in their build. And we create a similar one for tasks, right? So for each of my binaries, I might have several tasks that are responsible for producing the output of that binary. In the end, I get something like this, right? So I have my components, and I'm saying I have a foo component, it's of this given type, and I have a bar component that's of this other type. And here we're not giving it any further configuration, but I could go on to say, oh, and then my foo source is over here, and my bar source is over here. And my foo has this kind of source and this kind of source, et cetera. And then we wire it all up and say, so for my bar binary, I get a bar binary task that depends on its individual task that pops that guy out. And then I have a foo binary task that when I call that lifecycle task, it pops out my foo binary. So very quick rundown. But like Luke mentioned in his talk, we have some samples in the Grail distribution that basically describes how to do this, and it uses a markdown, where I take markdown syntax, and I define that as a component, and I run it, and I pump out HTML at the end as sort of an example of how to extend the software model to describe a new type of component, which is a markdown component. Right, so the other thing we didn't talk about was the model report, which is kind of like Gradle Tasks and dependencies, right? So it's just a textual report that we get, but instead it tells us everything that's in the model. So in this case, it would look something like this. If I run Gradle model, I get this big giant list. In this case, it's telling me, hey, I have a greeting, I have a polite greeting and a rude greeting. Polite has these options and those options, et cetera. Right? So if I want to know, hey, what all can I bind to, I can run this report. Just model. So you just run like the model task. Yep. So just wrapping up here. So some of the stuff we still want to do, we still want to bridge the gap between managed and non-managed types. So a lot of the stuff internally, especially the component, the software model stuff, is still built around non-managed types. So the idea would be that non-managed types are effectively going to go away, and everything's going to be managed. Right? So the other thing is to expose projects to rules so that you can at least do something cross-project stuff like Luke was saying before. The model DSL improvements, right? Some of that syntax still leaves something to be desired, and it's likely going to change. Right? So just keep in mind, yeah, the configuration rules, the software model is still under active development. Like everyone's using the latest nightly right here. Some of these features were committed last week. so keep that in mind. So with that, that's all I got. And if yeah, so what you're working on is 2.6. A lot of this stuff exists in 2.5 and earlier. Some of the collection type stuff is just very newer, and you can't use that. But everything you saw will be in 2.6. Yeah. Some of these features literally aren't in 2.5. They only exist in master in the 2.6 release. Right. Like I said, yeah, the build you're using was built like Monday. Right, and we've already branched 2.5, so some of the stuff won't be in 2.5. All right. Thanks, everybody.